Time ladies and time lords, welcome to a new taste of physics. I am the Doctor of Photonics, and I welcome you to a new journey through science. Today, I want to talk about Doctor Who. Hello, I'm Doctor Photonics. No, you may be a Doctor Photonics, but the Doctor Photonics. It's me. No, I am the Doctor Photonics. The second Doctor Photonics, to be more specific. Does that mean that I regenerate? Yeah, and some improvements that you think so. You've got a nice place here, but I've got to go. May the science be with you. So, anyway, where were we? Oh, yeah. The TARDIS. Doctor Who. The Doctor travels through space and time in his ship, the TARDIS, which is the acronym of Time and Relative Dimensions in Space. One of its most striking features is that it is bigger in the inside than in the outside. And when that character enters for the first time, you are waiting as a spectator to hear her say something similar.
It's called the TARDIS. It can travel anywhere in time and space. And it's mine.
It is. Look at it.
Go on, say it. Most people do.
Smaller on the outside.
Okay?
But what is true in a TARDIS? Can space be deformed this way? If we go to Einstein's theory of relativity, we find that in reality the dimensions of an object, the measurements of space, are not rigid. They can change. The dimensions of an object can be contracted so that we can put a 5-meter car in a 4-meter garage, for example. Albert Einstein realized that space and time depend on the speed of the observer. It turns out that an object that travels very fast will appear contracted to someone who is at rest. Also, the passage of time for someone moving very fast will be slower than for someone at rest. For someone at high speeds, their length contracts in the direction of the movement, and their times becomes relative. We can say that someone who runs a lot ages less and loses weight. Yeah, but that's a different point. For example, a 5-meter car traveling at 60% of the speed of light will measure just 4 meters seen by someone at rest. Here, v is the speed of the car, z is the speed of light, and making v large will make the ratio larger, and 1 minus the ratio will be shorter. This affects the car and the people in the car. If someone, Clara, drives a motorcycle, let's say that the bike measures 2 meters and wants to enter a certain police station that makes, let's say, 1 meter and 20. If Clara goes at 80% of the speed of light or faster, she can enter the cabin. Does that mean that relativity allows us to design something similar to the TARDIS? Well, it's not really that easy, because once Clara stops, the bike measures 2 meters again and it can't fit in a cabin. Another option is that the TARDIS was a portal, space-time portal, a place that connects the police station with another region in space, with which, when crossing the threshold of the TARDIS, it could be that the Doctor and Clara happen to be in another point in a galaxy or any universe, and when returning to cross the portal, they would be back on Earth. The TARDIS would be no more than a connecting door, so it doesn't need to be very large, and actually, once it's inside, you no longer occupy any volume on Earth. That's the idea of a wormhole, and this idea is very well presented in the movie Interstellar, 2014. The problem is that to create this, for the wormhole to be stable and not to collapse, we would need to have an exotic matter that has not been found yet in the universe. It has not been found so far. But who knows what Time Lords have learned from physics in all of this time? think that the TARDIS comes with its own book of mechanics. Advanced quantum mechanics, indeed. If you like Doctor Who, you can also learn science with him. And may the quantum mechanics be with you.